All right, Geometry, Chapter 4, Section 6, Congruence in Right Triangles. In this lesson, we're going to prove right triangle congruence by the hypotenuse-leg theorem, or HL theorem. So let's look. The hypotenuse-leg theorem says this: if a hypotenuse and a leg of one right triangle are congruent to the hypotenuse and the leg of another right triangle, then the triangles are congruent. That's what it's saying. So, if triangle PQR and triangle XYZ are right triangles, and the hypotenuses PR is congruent to XZ and a side PQ is congruent to XY, then the triangles are congruent. So to prove this, we're just going to walk through these steps real quick. We need to draw an auxiliary line. So the first thing we got given is triangle PQR and XYZ are right triangles with right angles Q and Y, and the hypotenuses are congruent. As you can see, PR is congruent to XC and PQ is congruent to XY, as you can see. So we're going to prove congruency. So here's what we're going to do. We're going to mark a point S, all right, and we're going to draw a ray ZY. Mark point S so that YS, this length right here, is equal to QR. Okay? And then triangle PQR is congruent to triangle XYS by side angle side. Since corresponding parts of congruent triangles are congruent, PR is congruent to XS. It is given that PR is congruent to XZ, so XS and XZ are congruent by the transitive property of congruence. So, by the isosceles triangle theorem, angle S must be congruent to angle Z, so the triangles are congruent by angle, angle, side. Therefore, the triangles are congruent by the transitive property of congruence. Okay? Again, we were able to prove triangles congruent, and so if we can prove congruent triangles congruent, we can get away with it. So here's the concepts that really matter for hypotenuse-leg theorem. Number one, the first condition, the two triangles have to be right triangles. They have to have congruent hypotenuses, and there has to be one pair of congruent legs. So there's those three things that must happen. All right, so problem one. On the basketball backboard brackets shown below, angle ADC, all right, is congruent to BDC, and they're the right angles, and AC is congruent to BC. Are they congruent? Our triangle ADC, I'll try to highlight that in yellow, okay, and BDC, kind of highlight that one in a darker color. Are they congruent? Why, yes, they are, because they both meet criteria. They're both right triangles. So they're both right triangles. The hypotenuses are congruent to each other. And we have a leg that's congruent to each other. Okay? So, by definition, or by theorem, they are congruent by the HL, or hypotenuse-leg theorem of right triangles. Okay, so problem two, writing a proof. So we got this diagram. BE bisects AD at C. So we know AC and CD are congruent because that's the definition of a bisector. Okay, we know AB is perpendicular to BC, so we know that's a right angle. And we know DE is perpendicular to EC. So we know that's a right angle. And we know AB, segment AB is congruent to DE. Okay. Prove ABC is congruent to DEC. Well, BE bisects AD, that's given. So we get AC is congruent to CD, which I already marked, because that's the definition of angle bisector. AB is perpendicular to BC, DE is perpendicular to EC. That is all given. I'm right over here. So triangle or angle ABC and angle DEC are right angles. Definition of a perpendicular line. So the triangles ABC and DEC are right triangles. That's the definition of a right triangle. So I've proven right triangle. I've proven a side that's congruent, or actually a hypotenuse that's congruent. And AB is congruent to DE. That's a leg. So here's my hypotenuse. There's my right triangle. And here's my leg. So by hypotenuse leg theorem, I can prove congruency. All right, let's look at this one. Given CD is congruent to AE, I mark that AD is the perpendicular bisector of CE. So that tells me I know this segment and this segment are congruent. All right. If I know angle CBD is a right angle, I know by vertical angles ABE is going to be right angle as well. So let's go through what's given. CD is congruent to AE, that's given. I marked on the screen. Angle ABE is congruent to DBE. That's the definition of vertical angles. The measure of angle CBD is 90 degrees. The measure of angle ABE is 90 degrees. That's the definition of right angles. CB is congruent to BE. That's the definition of a bisector. So I was able to prove the triangle's congruent because they meet the criteria. The hypotenuses are congruent, the legs are congruent, and they're both right triangles. So lesson check. Are the two triangles congruent? If so, write the congruency statement. Well, they're both right angles. Both of their hypotenuses are congruent, and both have a leg that are congruent. So yes by HL. Number 2, I have a side that's congruent, and I have a side that's congruent. But I'm not told these are right triangles, so we do not have enough information. Okay? That is it for lesson 4.6. Again, right triangles, hypotenuse leg theorems. We're looking for 3 criteria. They're both right triangles, their hypotenuses are congruent, and their legs are congruent. That concludes this lesson.